Hi friends, welcome back. The next issue to look at is about the context switching. Context switching is the process where the CPU stops executing one process and starts executing another. So it is the process where the CPU stops executing one process and then it starts another one. So one process which was running now will be stopped and made another process which was wait in the ready state to run. So the process which was running will now be changed to either ready state or waiting state or termination state, or the one which was waiting will now become running. So that is what a context switching is. So when the context is switched, that means if it is not being terminated, when the process is not being terminated and if it is stopped temporarily to allow some other process to continue its execution, then we should know where we had stopped this process, and when next time this process gets the chance to run, we should be able to start from the position where it had stopped and start executing from there. So for doing that, the operating system must save the state or the context of the current process and then should restore the context of the next process, which if it had stopped somewhere earlier and if it's supposed to start now, then that old environment has to be recreated and then it should start. So each process can resume exactly where it left off. Say it has A and B were the two processes working. A starts working. Sometime it is found that A should stop and B should come back, or B should start working. So A has done some part of it, and before giving control to B, A should save all its environment and the control is given to B, and B will start running, and after some time, the time for B is out, then A should again come back, then B should save its environment and then give control to A, and this switching takes place, and this switching is what we call context switching. So before going out, our process environment has to be totally saved so that next time when it comes back, the exact same environment has to be recreated before continuing the execution. Same way, when one process goes out and another process comes in, then it should recall the old environment when it was stopped earlier. What was the condition? The whole environment should be recreated before the next process is being started. So that is context switching. Context, the saving a snapshot of a process working environment. That's usually the process control block is what talks all about the context. So context, if you just look at what all details a context will have, so he talks about the CPU registers. When a process stopped working, what was the last instruction it has executed and what will be the next instruction that has to be executed. The next instruction to be executed in that process will be there in the process program counter. Then what are the stack contents and what was the top of the stack? The stack pointer has to be noted. Then general purpose registers, so many general purpose registers are there inside the processor. Contents of all these have to be noted down somewhere on the main memory, so that next time when we come back, that whole thing has to be copied and exactly as it was now. Program counter is the address of the next instruction to execute. Stack information that talk about local variables, return addresses, function calls, all details will be there in the stack. Then process state, it just says when it was running, what state it was in running state. Now when you stop it, what happens to that? Will it go back to ready state, or is it stopped because of some big event to take place, wait for a very long time? Then it should go to waiting state or block state and all that. And then memory mapping. So this process which is stored onto the main memory may be scattered in different positions, which we call tables, pages. So it just tells which pages occupy our process and all that. So this details about paging and all that will come the next session when we deal with the memory management. Then security informations like the privilege levels, user credentials, etc., all these bundled up. This whole thing talks about the environment of our process, and this whole thing is what we call a context. So why do we require context switching in the first place? So that is to support multitasking. That means multiple processes are sharing one CPU. So that makes things easier for many reasons. Number one, the response time of the user, that means a human, is in terms of seconds, milliseconds, and the response time of the system is in nanoseconds. Then if a process is stopped for few microseconds and the attention is given to some other process, and after a few microseconds our process again comes back to life, we can't notice that our process was stopped for few microseconds because our response time is in milliseconds and seconds. Therefore it is not possible for the user to know that the process was stopped for few microseconds or some nanoseconds. So that is quite impossible to know. So this whatever inability can be taken as a boon, and we can make many processes to run one after other in a cyclic way, so that anytime the CPU is allotted to one process, and for a short period the CPU is allotted to one process. So process A runs for some time, then B, then C, then D, and back A, B, C, D, A, B, C, D. So this way, if it is being run, then between two periods where A was running, it is so short period that we don't realize that A was not running for some time. So we feel that all A, B, C, D are running parallelly, as if for the slow user it appears as if A, B, C, D all four are running on four independent CPUs, but in reality only one CPU is there behind the scene, and this is time sharing is done. And because this time sharing is done for such a small period, we won't be able to notice that it is changing. The process is waiting and running, waiting and running, waiting and running. With this switching we can't notice, and this property can be made to use, and we can support multitasking very easily. And that's where the context switching is required, because ABCD, ABCD, ABCD. So when A has was forced to stop executing and given chance to B, then A should know where it had stopped, and next time after D A comes back, then where A had stopped earlier, the same place it should start. The whole environment has to be exactly the same. So that's where the context and the context switching comes into picture. So this another reason is when we want to switch between the user and kernel mode, So whatever user is working with, so it is working in the user mode. And if we want to get into the kernel mode, some system calls and all that will run in the kernel mode. So when we are shifting from user mode to the kernel mode, we should remember where what was the situation at that time of the user. Then when the kernel mode action is done, it will return back to the user mode, and while returning back it should recreate the whole environment again, so that we don't notice anything is lost. So we don't want to lose any information about the user mode when it goes into the kernel mode and all that. At the time of interrupt handling, yes, so we do use the interrupts. So whenever some interrupt, like a keyboard, reading the data from the keyboard, it is quite slow process, and we don't want our CPU to waste time on that, so we allot CPU to some other process, and the process which is waiting for the keyboard will go into the waiting state, and it will wait for the keyboard, some key to be pressed. So how does the process know that key is pressed? So whenever a key is pressed, the control circuit of the keyboard will send a interrupt information to the processor saying that key is pressed. So if you are waiting for this key, then you have input for you, so please read it. So when a key is pressed, the one which was waiting has to be shifted to the ready state. So for that some other process has to run, and while doing that, so context has to switch. So same way, multi-threaded systems, so when you are switching from one thread to another thread, then the whole environment of each thread has to be saved, and that's where context switching is essential.